In this video, we're going to be talking about input-output relationships, but this time our focus is on creating those function rules. So we are given a representation. In this case, it's a table, and they're asking us to write a function rule that represents it. So our goal is to figure out, well, what would we have to do to the input values to get the output values? So I'm starting with just one input-output pair. According to this table, if I put 1 into my function, I should get a 3 out. So my first guess might be, okay, well, I know that 1 plus 2 is 3, so let's try that rule. My output is equal to my input plus 2. So 1 plus 2 is 3. It works for the first one. 2 plus 2 is 4, which it doesn't work because according to my table, I should get 6. So I know that that rule does not work. So I'm going to try a second rule. My second guess is that my output is my input times 3 because I know 1 times 3 is 3. So 1 times 3 is 3, works for that one. 2 times 3 is 6, so far it's working. 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. So according to this table, my function rule of my output is equal to whatever my input is times 3 works. Each input-output pair makes that equation true. So this is the correct answer, and now we're just going to turn that into variables. So my output usually means y, my input means x, and then we have a times 3, and if we write that mathematically correct, we have y equals 3x. So now this rule, y equals 3x, represents not only this table of input-output pairs, but every single input-output pair that follows this same rule. So let's look at another example. At this table, we're going to do the same idea, right? I'm going to look at my first input-output pair is 1, 1. So I know that whatever I do to my 1, I have to get 1 out. Well, the only thing I really can think of is that it's the input times the input, right? So 1 times 1 is 1. So let's see if that works. So it works for that one. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. So this is the correct answer. So my output of y is equal to my input x times my input x. And if we write that mathematically correct, well, we know that x times x really just means x squared. So our function rule would be y equals x squared. I can use this rule then to figure out any input-output pair. So if I have an input of 7, well, 7 squared is 49, so I know my output would be 49. So this time they gave us a picture. We are talking about tables and how many chairs we can seat. So one strategy is to turn that picture into a table. So that's what we're going to do. We've got our inputs and our outputs. So my number of tables, the independent variable, those would be the inputs, and my output, the number of chairs, that's the dependent variable, are my y values. So I have this relationship, 1, 6, 2, 10, 3, 14. So again, we're just going to start taking some guesses. So my first guess, to get from 1 to 6, I know I could just add 5. So let's see if that's the right rule. 1 plus 5 is 6, so that works. 2 plus 5 is 7, but I'm supposed to get 10. So I know that that guess is incorrect. So let's try something else. From 1 to 6, I could just multiply by 6. Okay? 1 times 6 is 6, so that works. But 2 times 6 is 12, and I was supposed to get 10. So I know that that rule doesn't work either. Sometimes we can use the table and the picture together to kind of think about what's happening. So if I look at this picture, every time I add a table, it looks like I'm adding on 4 more chairs, right? So I've got 4 chairs on this edge, 4 chairs on this edge, and then the 2 at the ends. 4 chairs for each table, and then the 2 at the ends. 4 chairs for this table, and then the 2 at the ends. So it looks like I'm doing 4 times every table, which are our inputs, and then I'm adding an additional 2 every single time. So let's check to see if that works. 4 times my input plus 2. 1 times 4 is 4, plus 2 is 6. That works. 2 times 4 is 8, plus 2 is 10. 3 times 4 is 12, plus 2 is 14. So it looks like this rule is the one that works. So you can see how sometimes thinking about how your pattern is growing, a visual representation helps you identify the mathematical representation that goes with it. So let's write our rule. Outputs are y's, inputs are x's. And then if we just turn that into the mathematically correct format, we have y equals 4x plus 2. That makes sense in our scenario because I'm adding 4 chairs for every table, and then I always have the 2 chairs hanging out at the end. So one last one, we have a graph. And we're going to do the same thing. The strategy, we're going to turn that graph into a table. So my input outputs, I have these 3 points. Now here's the deal. You can pick any points. I could have picked this point down here. I could have picked this point up here, but you want to choose points that are on grid lines. I don't want to pick this point on my graph because I don't know exactly where that is. That looks like it's -1-ish, comma, -1-ish, right? I don't know exactly where that is. So make sure you're choosing points that are on these crosshairs, these grid lines. So if I take those points and put them in a table, that's the point 0, 1. That's the point 1, 3, and that's the point 2, 5. Now I'm going to start looking for my rule. Anytime you have a 0 in the table, it's a great place to start because I know the only way for me to go from 0 to 1 is by adding 1. So my rule has to have a +1 in it. But if I look down at my next pair, 1 + 1 is not 3. So I know that something else is going to be happening too. So I'm going to scoot this over and think about, well, what would that process be? So I know I have to add 1. So now I just need to figure out, well, what is this number going to be? What number +1 gives me my output? Okay, well, 0 + 1 is 1, 2 + 1 is 3, and 4 + 1 is 5. So now I'm looking for the relationship between these two values. I want to know, how am I going to get from 0, 1, 2 to outputs of 0, 2, 4? And it looks like that's just multiplying by 2. 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4. So that means my rule is going to be these outputs are going to be 2 times whatever these inputs are, and then I add 1 to it, right? 0 times 2 is 0, then +1 is 1. 1 times 2 is 2, then +1 is 3. 2 times 2 is 4, then +1 is 5. So our rule, if we turn that into our variables, our output of y is equal to our input of x times 2 + 1. We write it in the right order, and there is the function rule that represents the graph.